February 14th, 1944. Naval Air Station Espiritu Santo, New Hebrides. Lieutenant Robert Hanson stood beneath the wing of his F4U-1D Corsair, watching armament crews load belts of .50 caliber ammunition into the aircraft's expanded gun bays. The modification was recent, installed during his squadron's rotation back to rear area facilities. 4 additional Browning M2 machine guns now occupied space in the outer wing panels, doubling the Corsair's firepower from 4 guns to 8. What the Japanese defending Rabaul could not yet know was that this firearm enhancement, combined with the Corsair's existing advantages in speed and durability, would transform an already formidable fighter into a bomber-destroyer capable of shredding enemy formations with unprecedented lethality. The raid planned for tomorrow would demonstrate this transformation in the most violent terms possible, as Marine pilots discovered that 8 synchronized machine guns firing simultaneously created a cone of destruction that Japanese Zeros could not evade or survive. The standard F4U-1 Corsair, which had entered combat in February 1943, carried 4 Browning M2, .50 caliber machine guns, 2 mounted in each wing root. This armament, while respectable, placed the Corsair at a disadvantage compared to some contemporary fighters. The Republic P-47 Thunderbolt carried 8 R-50 caliber guns. The Grumman F-6F Hellcat carried 6. The Corsair's 4-gun battery delivered approximately 3,200 rounds per minute combined fire rate when all guns functioned properly. Each Browning M2 cycled at roughly 800 rounds per minute, though actual sustained rates varied with ammunition loading, barrel heating, and mechanical condition. The 400 rounds per gun standard loading provided approximately 30 seconds of firing time at cyclic rate, though pilots learned quickly to fire in shorter bursts to conserve ammunition and prevent barrel overheating. 4 guns firing. 50 caliber rounds delivered substantial, hitting power against lightly constructed Japanese fighters, but Marine pilots consistently requested more firepower. Combat reports from 1943 documented numerous encounters where Corsair pilots achieved initial hits on enemy aircraft without securing immediate kills. Japanese fighters, particularly the A6M0 and the Ki-43 Oscar, could absorb surprising amounts of battle damage when hits landed in non-critical areas. Their lightweight construction, while vulnerable to concentrated fire, sometimes allowed damaged aircraft to remain airborne long enough to escape or even continue fighting. Marine pilots wanted overwhelming firepower that would ensure immediate destruction of any target they hit. The solution emerged from field modifications undertaken by Marine aviation engineers at forward bases throughout the Pacific. The Corsair's wing design, with its distinctive inverted gull configuration, provided substantial internal volume in the outer wing panels. This space, originally left empty or used for minimal equipment, offered perfect locations for additional weapons installations. Engineers recognized that the wing structure could support the weight and recoil forces of additional machine guns without requiring major structural modifications. The challenge was integrating the guns, ammunition feeds, and firing mechanisms into the existing wing without compromising the Corsair's flight characteristics or requiring extensive factory rework. Marine aviation engineering units, working with limited resources at forward bases, developed installation procedures that could be completed in approximately 40 hours of maintenance time per aircraft. The work required cutting access panels in the wing's lower surface, fabricating gun mounting brackets from available materials, routing ammunition feeds from expanded wing bays, and connecting firing solenoids to the existing gun control circuits. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The additional guns were positioned in the outer wing panels, outboard of the main landing gear wells. This placement balanced the increased weight symmetrically across the wingspan, minimizing changes to the aircraft's center of gravity and roll characteristics. Each outer gun position received 400 rounds of ammunition, identical to the inner gun's capacity, bringing total ammunition load to 3,000 200 rounds across all 8 weapons. The combined weight penalty approached 400 pounds, including guns, ammunition, feeds, and mounting hardware. This additional weight reduced the Corsair's maximum speed by perhaps 5 miles per hour and slightly degraded climb performance. But these minor sacrifices were considered acceptable in exchange for doubled firepower. The outer guns fired through ports cut in the wing's leading edge, synchronized with the inner guns through mechanical linkages connected to the propeller shaft. This synchronization ensured that bullets passed through the propeller arc without striking the blades, a critical requirement for any forward-firing weapon on a propeller-driven aircraft. The synchronization mechanisms used cam-operated interrupter gears, mature technology dating to World War I, but refined through decades of development. The system worked reliably, provided maintenance personnel kept the timing mechanisms properly adjusted. Vought Aircraft, the Corsair's manufacturer, initially resisted field modifications to their design. Company engineers expressed concerns about structural integrity, fire control system complexity, and warranty implications. However, combat realities and pressure from Marine Corps leadership eventually led to official recognition of the 8-gun configuration. By late 1943, Vought began producing F4U-1D variants with 8-gun armament installed at the factory. These factory-built 8-gun Corsairs incorporated engineering refinements that field modifications lacked, including improved ammunition feed reliability, better gun bay ventilation to manage heat from sustained firing, and structural reinforcements optimized through engineering analysis rather than field expedients. The F4U-1D designation indicated these factory modifications, along with provisions for external ordnance carriage that transformed the Corsair into a capable fighter bomber. The 8-gun Corsair's combat effectiveness depended not just on the number of weapons, but on the geometric pattern their converging bullet streams created. The guns were bore-sighted to converge at approximately 1,000 feet, meaning that bullet trajectories from all 8 weapons intersected at that range. At convergence distance, the 8 guns created a roughly circular beaten zone, approximately 6 feet in diameter. Any aircraft within that circle would be struck by multiple bullets simultaneously, receiving catastrophic damage that no lightweight fighter could survive. Beyond convergence range, the bullet pattern spread progressively wider, reducing hit density but still providing reasonable coverage out to effective range of approximately 1,500 feet. Inside convergence range, the pattern had not yet fully converged, again reducing hit density but maintaining adequate coverage. The optimal firing solution occurred at convergence range, where all 8 guns placed their bullets into the smallest possible area. Experienced pilots learned to judge range and maneuver to achieve convergence distance before firing, maximizing the probability of immediate kills. The ballistics of .50 caliber ammunition contributed significantly to the 8-gun Corsair's lethality. The standard M2 ball round weighed 708 grains and left the muzzle at approximately 2,900 feet per second. This combination of mass and velocity delivered roughly 13,000 foot-pounds of kinetic energy at the muzzle, declining to approximately 8,000 foot-pounds at 1,000 feet. For comparison, a modern hunting rifle, firing .30-06 ammunition, delivers roughly 3,000 foot-pounds at the muzzle. A single .50 caliber hit carried more than twice that energy, sufficient to penetrate aircraft structures, fuel tanks, engines, and cockpit areas with ease. 8 guns firing simultaneously multiplied that destructive potential by a factor of 8, creating a combined energy delivery that approached 100,000 foot-pounds at convergence range. The physical effects on target aircraft were catastrophic. Japanese fighters, constructed primarily from lightweight aluminum alloys with minimal armor protection, disintegrated under concentrated 8-gun fire. Wings separated from fuselages, engines tore from their mounts, cockpits exploded as structure failed, and fuel tanks ruptured, often igniting immediately. Pilots rarely survived the initial burst, when all 8 guns achieved solid hits. The time required to inflict fatal damage decreased dramatically compared to 4-gun aircraft. Where a 4-gun Corsair might need 2 or 3 seconds of sustained fire to ensure a kill, the 8-gun variant could destroy targets in less than 1 second of firing time. This reduction in required engagement time provided multiple tactical advantages. Shorter engagements conserved ammunition, allowing pilots to engage more targets before exhausting their supply. Reduced firing time decreased the Corsair's vulnerability during attacks, as less time in predictable pursuit trajectories meant less opportunity for defensive fire or intervention by other enemy aircraft. Quick kills also provided psychological advantages, as pilots gained confidence in their ability to destroy any target they could track effectively. The standard ammunition loading mixed ball rounds with armor-piercing incendiary and tracer rounds in ratios that varied by unit preference and tactical requirements. A typical mix might be 4 ball, 1 API, and 1 tracer in repeating 6-round patterns. Armor-piercing incendiary rounds combined a hardened steel penetrator core with an incendiary compound that ignited on impact, particularly effective against fuel tanks and engines. Tracer rounds contained pyrotechnic compounds that ignited during flight, creating a visible trajectory that helped pilots adjust their aim. However, tracers also revealed the firing aircraft's position to enemy pilots, creating a tactical trade-off between improved accuracy and reduced surprise. Some aggressive pilots preferred minimal tracers to maintain surprise, relying on experience and gunsight accuracy rather than visible trajectory indication. The psychological impact of facing 8-gun Corsairs affected Japanese pilots profoundly. The distinctive sound of 8 Browning M2s firing simultaneously carried for miles, a rippling thunder that announced the Corsair's presence and capabilities. Japanese pilots who survived encounters with 8-gun Corsairs reported a fundamental shift in their tactical calculus. The maneuverable dogfight, cornerstone of Japanese fighter doctrine, became untenable against aircraft that could deliver fatal damage in fractions of a second. The margin for error vanished entirely when 8 machine guns could shred aircraft structure faster than pilots could react. Japanese tactical doctrine had emphasized individual combat skills, aircraft maneuverability, and aggressive pursuit of engagement. These principles worked effectively against earlier American fighters that required sustained tracking time to accumulate hits. Against 8-gun Corsairs, traditional tactics became suicide. Japanese pilots learned through bitter experience that they could not survive, turning engagements where Corsairs could bring their full firepower to bear. The doctrinal response emphasized avoidance over engagement, diving attacks from superior altitude, followed by immediate disengagement rather than sustained combat. This tactical shift acknowledged an uncomfortable reality. Japanese fighters could no longer compete in conventional air-to-air combat against the latest American fighters. VMF-214, reformed under the command of Major Gregory Pappy Boyington in August 1943, received 8-gun F4U-1D Corsairs during their second combat tour in late 1943 and early 1944. The squadron, later known as the Black Sheep, would become among the most famous marine fighter units of the war. Their combat record during the Rabaul campaign demonstrated the 8-gun Corsairs' capabilities against concentrated Japanese air opposition. Rabaul, located on the northeastern tip of New Britain Island, represented Japan's most powerful base in the South Pacific by late 1943. The base complex supported over 300 aircraft, including fighters, bombers, and reconnaissance planes. Multiple airfields provided redundancy and dispersal, while extensive anti-aircraft defenses protected the facilities from air attack. Japanese naval aviation units operated Rabaul, including some of the most experienced pilots remaining in the Imperial Japanese Navy's inventory. The base served as the linchpin of Japanese defensive operations in the region, supporting forces throughout the Solomon Islands and New Guinea. Neutralizing Rabaul became a primary objective for Allied air operations in late 1943 and early 1944. Rather than attempting a costly amphibious assault, Allied strategy called for sustained air attacks to destroy Japanese air power at the base and render the facilities useless without needing to capture them physically. This strategy, later termed island hopping, would become standard practice throughout the Pacific War. Marine and Navy fighter squadrons, including VMF-214, flew repeated strikes against Rabaul throughout December 1943 and January 1944. These missions typically involved fighter sweeps intended to draw Japanese fighters into combat, where superior American aircraft and pilot training could achieve favorable exchange ratios. The goal was attrition, systematically destroying Japanese aircraft and pilots faster than they could be replaced. The mission, planned for February 15, 1944, represented a maximum effort by Marine fighter squadrons based at Espiritu Santo and Bougainville. Intelligence reports indicated significant Japanese air strength remained at Rabaul despite previous strikes. American commanders wanted overwhelming force to achieve decisive results, scheduling multiple squadrons for simultaneous arrival over the target area. VMF-214 would provide top cover, flying at 25,000 feet to intercept any Japanese fighters attempting to attack lower formations. The altitude advantage, combined with the Corsairs' speed and heavy armament, gave Marine pilots every tactical advantage except numbers. Japanese forces at Rabaul still outnumbered the attacking formations, but American doctrine emphasized quality over quantity, trusting superior aircraft and better-trained pilots to overcome numerical disadvantages. Lieutenant Robert Hanson, flying with VMF-214, had already established himself as one of the squadron's top pilots. He had scored multiple victories during the squadron's first combat tour and continued adding to his total during the Rabaul campaign. Hanson's aggressive flying style, combined with exceptional marksmanship, made him particularly effective with the 8-gun Corsair's overwhelming firepower. His combat philosophy was simple: close to optimal firing range, achieve clean tracking solution, and destroy the target with a single burst. The 8-gun armament made this philosophy practical, where it would have been aspirational with lighter-armed fighters. The maintenance crews working on Hanson's Corsair the night before the mission understood their work's importance. 8 machine guns meant 8 opportunities for mechanical failure that could reduce combat effectiveness or leave the pilot defenseless. Each weapon received careful inspection. Barrels were examined for erosion or cracks that might cause burst barrels during firing. Bolts and receivers were cleaned and lubricated, ensuring reliable cycling during sustained fire. Ammunition feeds were routed carefully, avoiding kinks or sharp bends that might cause jams. Synchronization timing was verified using specialized tools that confirmed bullets would clear the propeller arc. This comprehensive maintenance took hours per aircraft but ensured maximum reliability when pilots' lives depended on weapons functioning perfectly under combat stress. The ammunition loading process required equal care. Belts were assembled with specific round patterns designed for fighter combat against lightly constructed enemy aircraft. The crews loaded 3,200 rounds total, filling every ammunition bay to capacity. Each round was visually inspected during loading to catch manufacturing defects or damage that might cause gun jams. Bad rounds were discarded, replaced with verified ammunition from carefully controlled stocks. The finished installation represented American industrial and maintenance capability at its finest. 8 precision-manufactured machine guns, 3,200 rounds of factory-produced ammunition, all integrated into a fighter aircraft capable of delivering that firepower at 400 miles per hour. The contrast with Japanese capabilities was stark. While Japan manufactured excellent aircraft designs like the Zero, their industrial capacity could not match American production volumes or quality consistency. Japanese pilots often flew aircraft with mechanical issues that would have grounded American planes. Their ammunition quality varied significantly, with some batches containing rounds that failed to fire or jammed weapons. These industrial limitations compounded the tactical disadvantages Japanese pilots faced, creating a cumulative superiority that would become overwhelming by 1944. The mission briefing began at 0500 hours in the operations tent at Bougainville's fighter. Strip 1. Major Gregory Boyington, commanding VMF-214, stood before a large wall map showing the 400-mile route to Rabaul and back. The intelligence officer pointed to known anti-aircraft concentrations, likely Japanese fighter patrol patterns, and escape routes if aircraft sustained damage, requiring emergency withdrawal. The mission profile was straightforward but demanding. Fly 400 miles to target area, engage Japanese fighters until ammunition exhausted or tactical situation required withdrawal, then return 400 miles to base with whatever fuel remained. Navigation would be challenging over open ocean with minimal landmarks until approaching New Britain's coast. Weather forecasts predicted broken clouds at 15,000 feet with clear conditions above. Visibility would be excellent, good for spotting enemy aircraft, but equally good for Japanese lookouts to spot incoming American formations. The tactical advantage would belong to whichever side saw the other first and secured altitude or a position advantage before engagement began. VMF-214 would lead the mission with 24 F4U Corsairs, all equipped with 8 50 caliber machine guns and full ammunition loads. 2 additional Marine squadrons would fly supporting positions, providing 48 total fighters for the strike. This represented substantial combat power, more than sufficient to engage whatever opposition Japanese forces could generate. However, intelligence estimates suggested Rabaul still housed over 100 operational fighters despite previous attrition. The Americans would be outnumbered roughly 2-1 if Japanese commanders committed their full strength. Major Boyington emphasized altitude discipline during the briefing. The formation would climb to 25,000 feet during the transit to Rabaul, maintaining that altitude until engaging enemy aircraft. The altitude advantage was critical, allowing Corsairs to convert potential energy into speed during diving attacks. Japanese Zeros could outturn Corsairs at lower speeds, but they could not match the Corsairs' dive speed or high-altitude performance. American tactics emphasized boom and zoom attacks, diving from altitude, making a single high-speed pass, then climbing back to altitude using superior power-to-weight ratios at high speed. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video, it means a lot to us. Now back to the story. The briefing covered emergency procedures in clinical detail. Pilots whose aircraft sustained serious damage had 3 options: attempt to reach friendly territory if damage allowed, continued flight, ditch in the ocean as close as possible to friendly forces and hope for rescue, or bail out over enemy territory and become prisoners of war. None of these options offered high survival probability, particularly the third. Japanese treatment of prisoners varied wildly, from occasional correctness to systematic brutality. Every pilot understood that the best emergency procedure was avoiding battle damage entirely through superior tactics and aggressive combat. Weapons procedures received particular emphasis. The 8-gun armament delivered overwhelming firepower, but consumed ammunition rapidly. Pilots were instructed to fire in bursts of 1 to 2 seconds maximum duration, allowing time between bursts for target assessment and ammunition conservation. Longer bursts risked overheating gun barrels, potentially causing malfunctions or reduced accuracy as barrels warped from extreme heat. The gun sight settings would be standardized across the squadron at 1,000 feet convergence, requiring pilots to close within that range before firing to ensure maximum hit density. Weather reconnaissance aircraft had launched earlier to verify conditions along the route. Their reports confirmed the forecast. Good weather with unlimited visibility above 18,000 feet. The timing could not be better for visual air combat, where superior speed, altitude performance, and firepower would decide outcomes. The pilots filed out of the briefing tent at 05:45 hours, walking through pre-dawn darkness toward the flight line where their Corsairs waited. Maintenance crews had been working through the night, preparing aircraft for the mission. Each fighter had been fueled to maximum capacity, approximately 360 gallons in internal tanks, providing roughly 1,000 miles total range at efficient cruise speeds. The mission profile called for 800 miles total distance plus combat maneuvering, leaving minimal fuel reserve. Pilots would need to manage fuel carefully during transit, maintaining optimal cruise parameters to ensure sufficient fuel reached Rabaul and returned home. Combat would consume fuel rapidly as engines operated at high power settings, but the alternative of insufficient fuel to engage effectively was unacceptable. Lieutenant Robert Hanson conducted his pre-flight inspection methodically, despite having performed the same routine hundreds of times. He checked control surface freedom and condition, examined tires for cuts or excessive wear, verified propeller blade condition, and inspected landing gear for hydraulic leaks or structural cracks. The external pre-flight took perhaps 5 minutes, covering items visible from the ground. Satisfied with the external condition, Hanson climbed the wing route and settled into the cockpit. The internal pre-flight checklist covered dozens of items. Flight controls moved freely through full travel. Trim tabs set to takeoff positions, fuel selector positioned correctly, mixture control full rich, propeller pitch control set for takeoff. The instrument panel displayed oil pressure, fuel quantity, cylinder head temperature, manifold pressure, and dozens of other parameters that would require monitoring throughout the flight. The gun sight, mounted above the instrument panel, was powered on and checked for proper illumination. The 8-gun fire control system received particular attention. Hanson verified the master arm switch was safe, preventing accidental firing during ground operations. Engine start procedures began at 0615 hours, with the entire formation starting engines in coordinated sequence. The Pratt & Whitney R2800 double wasp engine required careful starting procedures to avoid damage. The procedure began with several propeller blade rotations by hand, pulling the massive 4-bladed propeller through several revolutions to clear any oil that might have accumulated in lower cylinders overnight. Hydraulic lock from accumulated oil could bend or break connecting rods when the starter engaged, a catastrophic failure that would destroy the engine. With the propeller cleared, Hanson primed the engine with several shots of raw fuel into the intake system, energized the ignition magnetos, and engaged the electric starter. The massive 18-cylinder radial engine turned slowly at first, then caught with explosions from the priming fuel. Individual cylinders began firing as the ignition system provided spark to each in sequence. The engine accelerated to idle speed around 1,000 revolutions per minute, settling into the characteristic rumble of a big radial engine at idle. Blue smoke from incomplete combustion cleared as the engine warmed. Hanson monitored oil pressure, which rose immediately to normal range, and cylinder head temperatures, which climbed gradually as combustion heat transferred through metal. The engine instruments all showed normal indications within 2 minutes of start, confirming the power plant was ready for flight operations. Across the flight line, 2 4 Corsairs now sat with engines running, propellers turning in the morning air. The sound was magnificent, the combined thunder of 24 massive radial engines, each producing over 2,000 horsepower. The taxi sequence began at 0630 hours, with Major Boyington leading. The Corsairs moved in single file toward the runway, a long procession of angular fighters with their distinctive inverted gull wings clearly visible in the gathering dawn light. Rabaul lay 400 miles to the northwest, 2 hours flight time at cruise speed. The sun would be well up by the time they arrived, illuminating the combat area with the brilliant tropical light that characterized the South Pacific. Takeoff proceeded in rapid sequence with aircraft launching at 30-second intervals. Hanson's turn came midway through the formation. He positioned his Corsair on the runway center line, advanced the throttle smoothly to full power, and felt the massive engine accelerate the aircraft down the runway. The tail came up almost immediately as airspeed built. At 80 knots, the Corsair lifted off, transitioning from ground vehicle to flying machine in the space of 2,000 feet. Hanson retracted landing gear immediately after liftoff, reducing drag and allowing the aircraft to accelerate efficiently. The formation assembled at 5,000 feet, circling over the field as aircraft joined in their assigned positions. With all 24 Corsairs airborne and in formation, Major Boyington set course northwest toward Rabaul. The formation climbed steadily during the outbound transit, reaching 20,000 feet by the time they crossed the coast of New Britain. The climb to 25,000 feet continued during the final approach to Rabaul. arriving over the target area at exactly 0830 hours with perfect altitude advantage. The Japanese were waiting. Radar stations on New Britain had detected the incoming formation 100 miles out, providing Japanese fighter controllers sufficient warning to scramble interceptors and position them advantageously. Approximately 70 Japanese fighters, predominantly A6M0 variants, climbed to intercept the American formation. Japanese commanders committed nearly their entire available fighter strength, recognizing that allowing unopposed American raids would result in progressive destruction of their air power through attrition. The engagement began at 25,000 feet as American and Japanese formations merged. Major Boyington led the initial diving attack, rolling inverted and pulling through into a steep dive that accelerated his Corsair to over 400 knots. The speed advantage was immediately apparent. Japanese Zeros attempting to follow could not match the Corsair's dive acceleration. Their lighter wing loading and lower power prevented them from keeping pace as the Marines plummeted through 5,000 feet in seconds. Boyington selected a target, a Zero attempting to climb toward the American formation. The range closed rapidly. At 1,200 feet, Boyington centered the gun sight reticle on the Zero's fuselage and pressed the trigger. 8 Browning M2 machine guns fired simultaneously, sending 80 rounds per second downrange. The burst lasted perhaps 1 second. The effect on the Zero was catastrophic. The fuselage disintegrated as 50 caliber rounds tore through the lightweight structure. The wing separated from the fuselage, tumbling away in 2 pieces. Fire erupted immediately as ruptured fuel tanks ignited. The Zero fell apart in mid-air, transitioning from functional aircraft to wreckage in less than 2 seconds. Boyington pulled out of his dive and immediately began climbing back to altitude, converting his excess speed back into potential energy for the next attack. Behind him, 23 more Corsairs were making similar attacks, each pilot selecting targets and delivering devastating 8-gun bursts. The sky filled with falling Japanese fighters, some burning, others simply falling in pieces. Lieutenant Robert Hanson, flying as wingman in the second section, followed his section leader into the initial dive. He selected a Zero that had somehow evaded the first wave of attacks and was attempting to engage an American fighter below. Hanson dove nearly vertically, closing range rapidly. The Zero pilot, focused on his intended target, never saw Hanson approaching from his high 6 o'clock position. At 800 feet range, Hanson fired. The 8-gun blast lasted less than 1 second. The Zero's engine exploded, torn from its mount by multiple 50 caliber hits. The cockpit area disintegrated. The aircraft immediately entered an uncontrollable spin, falling toward the ocean 20,000 feet below. The engagement developed into a massive swirling dogfight as more Japanese fighters attempted to engage the Corsairs. However, the altitude and speed advantages held by the Americans proved decisive. Corsair pilots could dictate engagement terms, diving to attack when they held advantage and climbing away when Japanese fighters achieved temporary position advantage. The Zero's superior maneuverability meant nothing when Corsair pilots refused to engage in slow-speed turning combat. Japanese pilots found themselves in an impossible tactical situation. They could not catch diving Corsairs, could not follow climbing Corsairs, and faced instant destruction when Corsairs achieved firing position. The 8-gun armament eliminated any possibility of survival through evasive maneuvers. A single 1-second burst from converged 8-gun fire destroyed aircraft immediately, leaving no opportunity for the pilot skill or aircraft maneuverability that Japanese doctrine emphasized. The engagement over Rabaul on February 15, 1944, lasted approximately 25 minutes from initial contact to final disengagement. In that span, VMF-214 and supporting Marine squadrons claimed over 70 Japanese aircraft destroyed with varying degrees of certainty. Post-mission intelligence analysis, incorporating reconnaissance photos and Japanese records captured later, confirmed at least 60 Japanese fighters were lost during the engagement, representing roughly 85% of the defending force. American losses totaled 3 Corsairs, with 2 pilots recovered by rescue submarines and 1 killed in action. The kill ratio exceeded 20-1, representing one of the most lopsided aerial victories of the Pacific War. The tactical factors enabling this outcome were multifaceted, but clearly documented in after-action reports. The Corsairs' speed and altitude performance provided American pilots with complete control over engagement geometry. They could attack when holding advantage and disengage when disadvantaged, a flexibility Japanese fighters could not match. The 8-gun armament reduced the time required to destroy targets from several seconds to less than 1 second, minimizing the Corsairs' vulnerability during attacks and allowing pilots to engage multiple targets in rapid succession. Lieutenant Robert Hanson personally accounted for 4 confirmed kills during the engagement, bringing his total to 20 victories and establishing him as one of the top Marine aces. His combat report described the 8-gun Corsairs' effectiveness in clinical terms. Targets disintegrated under concentrated fire faster than pilots could react. Evasive maneuvers proved useless once the Corsair achieved firing position. The engagement range had decreased to 800 feet or less because the overwhelming firepower made longer-range shooting unnecessary and wasteful. Close-range shots, with all 8 guns converged, delivered certain kills with minimal ammunition expenditure. Hanson's tactical approach evolved to emphasize positioning and patience over aggressive pursuit. With firepower sufficient to destroy any target instantly, the critical skill became achieving optimal firing position rather than maintaining that position for extended periods. He would maneuver carefully to position his Corsair at the target's high 6 o'clock position, then dive to close range rapidly, fire a single 1-second burst, and immediately break away to set up the next attack. This methodical approach maximized efficiency and minimized risk, allowing him to engage 4 separate targets during the 25-minute engagement while conserving sufficient ammunition for potential follow-on missions. The psychological impact on surviving Japanese pilots was profound and well documented through post-war interviews and captured documents. Japanese fighter pilots at Rabaul after February 15th reported to their commanders that continued combat against 8-gun Corsairs was tactically impossible, using existing doctrine. The maneuverable dogfight, cornerstone of Japanese naval aviation since the 1,930 had become a death sentence against aircraft that could destroy targets in fractions of seconds. Japanese pilots described a feeling of helplessness, knowing that any American pilot who achieved firing position would score an immediate kill regardless of evasive action. The only effective defense was preventing Americans from achieving that position, which required either superior altitude advantage or numerical superiority sufficient to overwhelm the Americans through sheer numbers. By February 1944, Japanese forces possessed neither advantage consistently. The doctrinal response from Japanese Naval Aviation Headquarters emphasized avoidance over engagement. Fighters were ordered to intercept only when, holding clear advantage in altitude and numbers. When American formations approached with superior position, Japanese fighters were instructed to withdraw rather than engage in unfavorable combat. This defensive posture represented a fundamental admission that Japanese fighters could no longer contest American air superiority over critical areas. The 8-gun Corsair had transformed the tactical balance so decisively that Japanese forces could only survive by avoiding combat. The implications for broader strategic operations were immediate and severe. Without effective fighter cover, Japanese bombers could not attack American naval forces or ground installations. Without air superiority, Japanese ground forces received no air support and faced constant harassment from American air attacks. The air war in the South Pacific effectively ended as a contest by mid-1944, with American forces achieving operational air superiority that Japanese forces could not meaningfully challenge. The February 15th engagement demonstrated capabilities that would be replicated throughout the Pacific campaign as more Marine and Navy squadrons received 8-gun Corsairs. Production of the F4U-1D variant accelerated through 1,944, with Vought factories producing hundreds per month by summer. The 8-gun configuration became standard for all new Corsair production, with 4-gun variants relegated to training roles or modified to 8-gun standard during maintenance cycles. The widespread deployment of overwhelming firepower multiplied the tactical advantages observed at Rabaul across the entire theater. By late 1944, Japanese fighter pilots throughout the Pacific faced the same impossible tactical situation their colleagues at Rabaul had encountered. They could not survive conventional combat against aircraft armed with 8 synchronized 50-caliber machine guns that could destroy targets in single 1-second bursts. The Japanese response evolved toward kamikaze tactics, recognizing that conventional aerial combat had become suicidal against technologically superior American fighters. If Japanese pilots could not survive air-to-air combat, perhaps they could achieve some effect by deliberately crashing into American ships, exchanging certain death for potential damage to high-value targets. The emergence of kamikaze tactics in late 1944 represented Japan's acknowledgement that their air forces could no longer compete conventionally. The 8-gun Corsair contributed significantly to the calculus that drove this desperate tactical evolution. Lieutenant Robert Hanson continued flying combat missions through February 1944, adding to his victory total with aggressive flying and exceptional marksmanship. On February 3, 1944, he scored 5 victories in a single mission, demonstrating the 8-gun Corsair's capability to engage multiple targets in rapid succession. His total reached 25 confirmed victories by early February, making him one of the February top-scoring Marine aces of the war. Tragically, Hanson was killed on February 3, 1944, when his Corsair crashed during a strafing run against Japanese ground positions on New Britain. The loss of such an effective combat pilot highlighted the fundamental danger of low-altitude operations, where enemy ground fire threatened even the most skilled aviators. Hanson received the Medal of Honor posthumously for his actions during January and February 1944, including the February 15th engagement over Rabaul. His citation specifically noted his aggressive spirit, exceptional marksmanship, and the 25 enemy aircraft he destroyed in combat. The 8-gun Corsair's combat record extended far beyond the Rabaul campaign. Marine squadrons flew F4U-1D variants throughout the Philippines campaign, the Iwo Jima invasion, and the Okinawa operation. Navy squadrons operating from fleet carriers achieved similar success using the 8-gun Hellcat, which incorporated identical armament philosophy in a different airframe. The cumulative effect was decisive. Japanese fighter forces, already weakened by attrition of experienced pilots during 1942 and 1943, faced American fighters in 1944 and 1945 that combined superior performance with overwhelming firepower. The technological gap that had been significant in 1943 became insurmountable by 1944. Statistics compiled from official records document the Corsair's overall effectiveness. F4U Corsairs achieved 2,140 air-to-air victories against 189 losses to enemy aircraft during World War II, an 11-to-1 kill ratio. While these figures include both 4-gun and 8-gun variants and reflect multiple factors beyond armament alone, the combat record from Rabaul and subsequent campaigns clearly demonstrates the 8-gun configuration's substantial contribution to this success. The industrial dimension of the 8-gun Corsair program deserves emphasis. American factories produced over 12,000 F4U Corsairs during World War II, with approximately 60% incorporating 8-gun armament. This production volume, combined with sufficient ammunition manufacturing to keep these aircraft supplied, represented industrial capability that Japan could not approach. Japanese factories struggled to produce 10,000 Zero fighters during the entire war, operating under constant materials shortages and facing progressive destruction from American bombing. The contrast in industrial capacity, combined with technological and tactical advantages, created cumulative superiority that decided the Pacific Air War's outcome. The ammunition consumption of 8-gun Corsairs placed enormous demands on American logistics systems. Each aircraft carried 3,200 rounds of 50 caliber ammunition. A squadron of 24 aircraft required 76,800 rounds for a single combat mission. Marine air groups supporting multiple squadrons consumed millions of rounds monthly during intensive combat operations. This ammunition had to be manufactured in American factories, shipped 6,000 miles across the Pacific, and distributed to forward bases throughout the theater. The logistics system supporting this ammunition flow represented organizational capability as important as the weapons technology itself. Japanese forces faced chronic ammunition shortages throughout the war, with pilots sometimes ordered to conserve ammunition by firing single guns rather than full armament. American pilots never faced such constraints, firing full 8-gun bursts without concern for ammunition availability. The maintenance burden of 8-gun armament increased proportionally compared to 4-gun configurations. Each weapon required regular cleaning, lubrication, and inspection. Barrels wore out after sustained firing, requiring replacement. Ammunition feeds needed adjustment to prevent jams. Synchronization timing required periodic verification and correction. Marine aviation maintenance units adapted to these demands, developing procedures that kept 8-gun Corsairs operationally ready despite the increased complexity. The maintenance challenge was managed through systematic organization rather than technical brilliance. Detailed procedures specified inspection intervals and maintenance actions. Spare parts were stocked in sufficient quantities to support expected replacement rates. Technicians received training on the 8-gun system's specific requirements. The result was high operational readiness rates that kept maximum numbers of aircraft available for combat missions. The post-war evolution of fighter armament reflected lessons learned from the 8-gun Corsair and similar programs. The immediate post-war generation of jet fighters continued using multiple machine gun or cannon armament. The F-86 Sabre carried 6 50 caliber machine guns. The MiG-15 carried one 37mm cannon and two 23mm cannons. These designs acknowledged that gun armament remained necessary despite the emergence of early air-to-air missiles. However, by the 1960 seconds, fighter design philosophy shifted toward all-missile armament, reflecting confidence that guided weapons had rendered gun combat obsolete. This confidence proved premature during the Vietnam War, when American fighters armed only with missiles found themselves disadvantaged in close-range combat against more agile North Vietnamese fighters. The Air Force responded by developing gun pods for external carriage, and eventually incorporated internal cannons in later F-4 Phantom variants. The Navy established the Top Gun Fighter Weapons School to improve air combat effectiveness. These responses acknowledged that gun armament remained relevant despite technological advancement in missile technology. Modern fighters like the F-15, F-16, and F/A-18 all incorporate internal cannon armament alongside sophisticated missile systems, representing a return to the multi-weapon philosophy that characterized World War II fighters. The specific implementation changed from 8 50 caliber machine guns to single 20mm rotary cannons, but the underlying principle remained identical. Fighters needed gun armament for situations where missiles were impractical or unavailable. The 8-gun Corsair's legacy lives on not in museum aircraft or historical records alone, but in the continued presence of gun armament on modern fighters. The lessons learned at Rabaul and throughout the Pacific Campaign demonstrated that overwhelming firepower provided decisive advantages in air combat. Those lessons influenced fighter design throughout the jet age and continue influencing doctrine today. The story of Japanese forces never expecting 8 50 caliber machine guns until Corsairs shredded 70 Zeros over Rabaul in one day represents more than just a single engagement's tactical details. It represents the intersection of technology, tactics, and industrial capacity that determined the Pacific War's outcome. The 8-gun Corsair exemplified American approaches to military problems. Identify the requirement, develop a technical solution, produce it in overwhelming quantities, and employ it effectively through sound doctrine and well-trained personnel. This systematic approach proved decisive, not just in individual engagements, but across the entire campaign. The engagement over Rabaul on February 15, 1944, provided dramatic confirmation of capabilities that would shape the remaining 18 months of the Pacific War.